These are the 7 bridges of Königsberg. Legend has it, the people who lived there liked to go on Sunday walks about the city and try to cross all 7 bridges only once. Well, do you think it's possible? Well, my first try didn't work, because I started at 5, went over these bridges, then went over these bridges, and then went over these bridges, but I still haven't hit bridge number 3. But I'm stuck up here because I've already used all 3 of these bridges, and no one in the city could find a path that worked. When it comes to math, saying I can't do it and it's impossible are two different things. The latter requires a mathematical proof. Lucky for Königsbergians, the famous 18th century mathematician Leonard Euler lived in somewhat nearby St. Petersburg and reluctantly decided to come up with a proof. And he recognized that a lot of what usually matters in math is irrelevant here. It's like a geometry problem, but measurements, calculations, and even the sizes of the bridges and the land masses is irrelevant. So this is the same as this, which is the same as this simple graph. And you can see that each node on this graph here has an odd number of connections. But once you get to a node with one bridge, you have to leave the same node with another bridge, actions that come in pairs. That means for it to work, each node or landmass has to have an even number of connections, with one exception. That exception actually happened in World War II when 2 of the bridges were destroyed in air raids. And if only 2 of the nodes have an odd number of connections, then you can start on one odd node and make your way all the way around back to the other odd node, and that's called the Eulerian path. But if every node on the path has an even number of connecting points, then you can make what's called an Eulerian circuit by hitting every node and every path and returning to your starting point. So in this case, it was impossible to hit every bridge only once without going for a swim.